My name is Casandra Martin, and these are my partners.
Nathan Kistler.
And Ricardo Castaneda.
Our project is called Farm Sold Moisture Data Collection, and our advisors are Dr. Satya Narayanan and Dr. Young Jun. The problem we addressed in our capstone was the drought that the Salinas Valley is experiencing. Agriculture is the main industry in the area, and farmers have been having a hard time maintaining their crops because water just isn't as available. The Salinas Aquifer is the main water supply for the crops, and it's been overdrawn in the last few years with little or no rainfall to fill it back up. This leads to saltwater intrusion from the bay, and saltwater is very bad for the crops. There's also no real efficient way to manage the soil and keep it monitored, which in turn leads to poor decision making and inefficient watering. And the little data that is collected on the soil isn't open source, so it can't be viewed by others, which is a problem because it's valuable data that should be shared.
So for our solution, we wanted to create a system that sort of addressed all the needs of all the stakeholders involved. To do this, we needed to create a database that sort of identified which variables we needed to track, as well as who would have access to what data. We needed to create a desktop and mobile application to provide the maximum ease of access to our platform. And near real-time access to soil data actually allows for better outcomes in terms of water management and conservation. So for our methodology, for our research that involved talking to some of the stakeholders involved in Salinas Valley agriculture and water, for our database, we needed to develop something that was scalable, could be used in the future to grow. For integrating our hardware and software, that involved integrating a number of platforms across various frameworks. For our web page and mobile development, that allowed for just ease of access to data. For deploying to test sites, that allowed us to actually make sure our system would work. And for open sourcing it, that allowed us to maintain our system a little bit better, as well as entice users to use it. This is a photo of one of our test sites with one of our nodes in the ground.
So after completing our research, these are the tools that we decided to use to complete our project. We decided to use the on-set wireless sensors and receiver to measure the soil moisture and generate the data for our system. We also needed a web hosting service that could allow us to remotely access the data from any location. Besides that, we used Java, Eclipse, PHP, MySQL, HTML, and Array to develop all the code necessary for our Android and website application to work. We also use Google and Weather API keys to get current location and forecast information as additional resources in our site. Through all these years working on this project, we learned a lot about the water problems that cities that depend on agriculture, like Salinas, are facing. We learned that there are multiple solutions and options, but due to commercial competition, none of these solutions offers any openness for study and research. We also learned how to manage a project of this magnitude, overcome the obstacles that presented, and manage to accomplish our deadlines for the successful completion of the project. We also practice and learn the programming concept that help to build the solution of our project.
So we'd like to thank our advisors and Ann Gibbon and the Rodriguez and Mendez families. If you're interested in learning more about our project, visit us on our website.